Hello, I am AlanHorton and this is my mechanics overview for heads and tails. I will first talk about the build mode mechanics. In the build mode, the player has a camera that can move via screen edge, rotate, zoom in and out, and pan up and down. This is done by guessing the world position of the camera and changing the transformation of it. The zoom in and pan has a clamp to stop it from clipping. The screen movement is done by adding local offsets. The grid system uses two types of systems, a visual grid that can be seen and a grid system that runs off the mouse cursor, and this locks the item to a grid size of 128. In the master item, it runs a check on the collision channel to see if the item can be placed. Once the item is placed, it gives each item a unique ID number. This enables the items to be reselected. When reselected, a submenu appears which has four options. To move, which follows the mouse cursor again. You can rotate it 90 degrees and you can accept the new position or cancel any changes. Each item runs off a master item. It gets all the variables from a strut, which is set by a data table. In this data table, it sets the model, name, cost and any other information that is needed. I will now be talking about the movement and interaction system. The system now uses a point and click with the left mouse button instead of using the old method we had of using the WASD keys. It makes it just a click to the area you want to move to. This gets the mouse's position and moves the actor to the hit location. The player's interaction system uses the left mouse button as well and uses an event on clicked. To stop the interaction happening anywhere in the level, it gets a distance from the player's character to the actor being clicked and checks to see if they are within range. If true, it will perform the task. In the video, it shows the player picking up the item, which just transfers the strut information over to the player. The pet mood system. This system is all about caring for the pets. It uses a mood ball that takes the overall float variable of all the moods and uses that to drive a dynamic material instance. The moods show how happy the pet is, and alongside this, it shows emotes as visual feedback. The moods are on a timer, and every second it removes a decimal from the two floats. These two floats are hunger and happiness. These slowly get lower over time. The pet can also get sick. It uses a random probability function to determine when it gets sick. If the pet is left unattended, it will finally run out of mood and the animal welfare will come and take the pet away, which just gets the location of the pet. The pet minigames. Each mood has its own minigame. The cleaning minigame increases the happiness mood. The user must click on the soap bubbles to complete the game before the timer runs out. The feeding minigame increases the hunger mood, and this is done by clicking the mouse button on the screen, and this gets the value of the bar position and adds it to the mood. The vet minigame restores the pet's health to full and is only really needed to be used when the pet is sick. Depending on the game, it uses an enum and a switch to determine how the player did. This will either end the game or add 0 to the mood for that round. After the minigame has completed, it adds the values to the respective moods, increasing the happiness. The AI mechanics. The AI enters the store and requests a random item. The AI will only request items that the player has placed in the shop, and these are added to an array. The AI has a simple behaviour tree. One, it patrols around the shop, and the other, it moves to the exit waypoint. The AI also has two states, a win state where the user gives the correct item and it will leave the store happy, and a lose state where they will storm out and if they receive the wrong item or the player does not interact with them. And finally, the character customization. This enables the user to be able to customize their player. It uses animations in the widgets to slide out the bar or the coil wheel. The character was set up in a unique way so I could implement the materials with a grayscale mask in the materials. This is what gives the character a checked outfit look. The eyes are animated using a sprite sheet using a flipbook material node. The eyes and mouth use their own planes and UV coordinates. The mechanics behind the customization is fairly simple and it's just about using the material instances to change the colours, models, images and skeletal meshes. The colour wheel is a little bit trickier, and this requires breaking down the mouse position on the canvas over the screen scale into a float and getting all this information turned back into a linear colour to change the materials using the wheel. Thank you for taking the time to watch my video.